Okay, let me actually say it again. So in this class, we're going to talk about the Java. How can we use the Java to create objects? So now in all the actual Java programs we talk about so far, we know that we need to define a class and define a main method, and then we can put the Java code in there. It doesn't matter how simple your Java code is going to be. So even like your Java code is going to actually simply just print a statement, a string, and you still need to create a class and you still need to create a main method. Okay, and then you can create your own user-defined method. But so far, all these methods we talk about, we always put the keyword called static in there, and these methods are called a class method. So that means even though it's called a class method, but these method has nothing to do with the class itself. It's just the method is actually housed in this class. It's defined in this class. Uh, so the context of a method could be anything, doesn't have to be related to the particular, you know, contents of this class. So now when we try to create a Java object, then we need to create some methods called member methods. And for the member methods, it's actually going to actually some kind of this method going to somehow used to describe or used to perform the operation for the class we define. Okay, and if we define a member method, we should not use the keyword static. Okay, for example, we define a class called car, and we can define a method, a member method called start, which is a public method and does not return anything, and we can implement the method start. And we can actually define another class called stop, so we can stop the vehicle, a car. Okay, and then so you can say how to actually do the stop. So you can say, you know, press the actually brake pedal, right? So then we stop the vehicle. And then we can define the characteristics of the class. It's called a field variables. Uh, so it could be, we can define the model of the class. You can define the make of the class. And you can also define the color of the class. These are all string variable. Okay. So this way we can define a class, and then we can use the class to create objects of the class. Now, if the class name is called car and the object of this class many times it should be called my car, Brady's car, Mary's car, John's pickup, something like this. Okay, so which basically talk about each instance of the car, and these objects basically have the same general characteristics, but each individual object has its own individual name, individual value for each of the variables. For example, Brady's car may have the value like a model is Highlander, a maker is Toyota, and the color is um, red. So, and John's pickup could be, the maker could be Chevy, and the model could be, I'm not familiar with pickup. Let's say maker is Ford, and the model is F-150. That's the famous one. And the color is white. Okay. So, each object basically has the same variables, has the same attributes. each vehicle has its own maker, model, color, but the value for each of the variables is different. Okay.
Professor, could you give an example in using car as an example? What might a static method be?
If you talk about a static method, then your method doesn't have to be related to the operation of the car. You can just define a static. You just you can even define say static method, and you can define your own operation in this method, and this operation has nothing to do with car. That could be a possibility because it's not related to any instant. So if it's statical, that means this approach, this method is basically it's a general method for all its instance, all its object. It doesn't really matter. It's not related to a particular object.
So like a list of all the cars might be a static method because it doesn't have to do with any one specific instance of a car.
That's correct. If it's not related to the instance of the vehicle. So we'll talk about this a little bit later because the statical, you will find out actually the statical is because people want to define a method. They want to use the method, but they cannot define a method like Python. You can define a method, just randomly define a method, and without putting this method in any class because it's not required for Python, right? But for Java, every program has to be in a class. So you want to create a method, but you have to create this method in a class. And you want the method that has nothing to do with the class. It's just a method I want to define. Then you can put a static. You see the point here?
So the class car would actually maybe be unlikely to have any static methods in it.
Mostly it should not. But if you want, you can always put any method which is unrelated to the car in the class called car. You can do that, but that normally doesn't make any sense, right? But technically, in terms of syntax, you can do that.
Okay.
Yeah, but for most of, but oh, I take it back. There's always one statical method called the main method. That's always statical, and this is actually the entry point for all the programs. So you can put the main method in the car, but that main method should be static. But that main method may not be related to the car. It's probably gonna be, just your start point for your program. So you can actually, in your main method, you can, declare an object of the car. You can declare two objects of the car and many different objects of the cars. You can do this, but that's a statical method.
So I know you explained this earlier, but I didn't quite understand. Each program has one main method, or each class has one main method?
Each program has one method, but you can put the main method in any of the class.
Would you ever have a main class?
Yeah, for example, if your program had you have to define 100 classes, right? And but your main method, you should only have one main method, and you can put your main method in any of the class. So that's why the statical method really doesn't matter where you put the statical method. If you want to put the statical method in this particular class, and then the whole program gonna start from this static, main method. And you can put the static main method in another class. It doesn't matter. It's still, you can still do the job.
I think I understand. Thank you.
Yeah. So the statical is basically, it's just that, you can put a static in any of the class for this program. It really doesn't change anything. It's just the same. You just need to realize, okay, this statical method is in this particular class. Okay. But the contents of the class has nothing to do with the object of this class, any instance of this class. I think we need more practice to understand more what does it mean, But let's actually just go over, summarize these class and object, and then we're going to jump to an example. Let's say, okay. So in programming, an object is a grouping of data and operations, and these operations can be performed on this data. Okay. Sometimes data is also called, so when we define the object, the data of the object is called the attribute. Okay. Or sometimes they call the characteristics of the object. Okay. Attributes, characteristics, whatever you call it. And the operation sometimes called basically a method, right? And in particular, for most of the object or class, we also call the operation a behavior. Okay, behaviors. So these operations basically used to manipulate the data. Okay. In this object. Okay. So now when we try to use the Java class to do, we try to use the Java class to do the purpose for the Java class is to achieve something called abstraction. Okay. So what is abstraction? Abstraction basically means to have a user interface with an item at the high level and with low level internal details hidden from the user. Okay. And we call this abstraction sometimes called information hiding or encapsulation. Now, back to the example of the class called car. And then when we create the car, we can define all these attributes, all the data related to a car, right? So make, model, color, year, whatever, or owner of the car, right? So we can just create all this data for the car. And we also create all these operations of the car. So we just say, okay, to get the information about the car, and that's the operation. To start the car, stop the car, and these can be defined as methods. Okay. So, however, when we define all these attributes, the maker and everything, now we want to organize this data in a very nice way. Okay. So we only want people to, um, just access all the interface we provide for the car. Okay. So, and we don't want people to know the details of these vehicles. For example, if you want to implement a method called run, like in the autopilot driving, so we can just say run, and then it can actually particularly operate the vehicles. So now from user perspective, once I create an object, once I create the class called car, and I create the object of the car, say my car, I don't want to know the details of the vehicle, how the car is running. So take it that way. So for a car, if you buy a car, okay, you can interpret this as an object of a car. That's my car. And you can buy different model, different maker. So my car, And then when I sit in the car, okay, I can drive the car. Why I can drive the car? Because I can read the manual and say, oh, there's a transmission. So with the transmission, I can shift the gears to like a parking, drive, reverse. So I can actually use this transmission to manipulate my vehicles. Okay. And then I can just press the gas pedal to accelerate, to start the vehicle. And I can brake, press the brake to stop the vehicle. Okay, so I can operate the car, right? As far as I know all the functionality of the car. So you can interpret this like a functionality, like the transmissions, gas pedal, and you can interpret this as the operations, the methods provided by the car. Now, when you operate the car, do you need to know how this car is actually operated? So when you shifted gear and then you know, oh, here's driving, do I have to know how the car drives? How the car drives? The answer is no, right? I don't have to know this because the manufacturer, when they actually make all this vehicle, so if I don't have to open the car to see how the car drives. I don't have to know all these gears. All I need to know is when I actually shifted the transmission, I can operate the car. That's basically the idea of information hiding or encapsulation. Now, when we create a Java object, we want to do the similar kind of activity. So we want to create all these methods, and we want the user to use these methods to manipulate the data in this class object. But the user doesn't have to know how these methods are implemented. So they don't have to know this. That's the encapsulation we want to achieve. Because then once you actually create all these objects and then you just tell people, okay, I create this class. This class has this and this, and then once you create the object of this class, you can, manipulate the data inside this class. And people say, wow, that's good. All I need to learn is I need to learn how to use each of these methods, you provide. These methods allows me to control these data. Okay, so that's the encapsulation or information hiding or abstraction, whatever you call it. So Java basically achieve this using abstraction, and we also use the terminology called abstract data type. So it's a data type whose creation and updates are constrained to specific well-defined operations. Okay. So you can manipulate the data, but you cannot directly change data, but you have to use the interface, the methods provided by the creator of this object, this class. Okay. So let's can just continue. So basically, the class constructor defines a new type that can group data and method to form an object. Now you can think about this. The class, you can view the class as user-defined data type. Okay, user-defined data type, just like a string. Okay, when you declare string is, you can interpret string as a class, which is created by other people, because string is so popular because everybody use the string. It's useful in Java program. So people actually put the string class in the library so people can call the string and without actually knowing how this string is created. So only thing I need to know is how I can use the string. So I can declare a string, says my string. Okay. Now for the class, it's just a kind of data type you just create by yourself. Okay, it's a particular type. Okay, so you can interpret my string is an object of a string, right? Or object of string type. Now same thing with class. You can define your own class, and this class contains data and also methods. Okay. Now a class method, a class's public member methods indicates all the operations a class users can perform on the object. So like the car, we define a method called run, stop, accelerate. So these are all different methods that are used to manipulate a vehicle. Okay. And a class has has private fields. The private fields are the variables that the member methods can access, but the class user cannot. Okay. Now we can talk about this a little bit later. Okay. So the power of the class is that a class user need not to know how the class's data and the methods are implemented, but need only understand how each public method behaves. So you don't have to know the detail of the implementation of a method, but you just need to know how to use the method to manipulate the class. This is the idea of, once people invent the wheels, you don't have to invent the wheels. You just need to know how to use them. Okay. So let's say how to use the class. Okay. We'll be back to this slide, but we can first actually try to show an example. So here is an example. Okay. Now in this example, we created two classes. Actually, you don't have to create the two classes. You just need one class. But I did with two classes. I will show you both. Okay. So I can define a class called restaurant. Okay. Now this restaurant class has three methods. Okay. Now these three methods are going to be used to manipulate two actually class field or two variables. One of the variable is called a name, which is actually string type. The other variable is called a rating, which is integer type. So name is a string, rating is an integer. Now I put the private here. Okay. Now I'm going to talk about this later. Why? So I put the private here, and then the method called set name. It's a public method. Remember that we get rid of the static keyword, right? So that means this method is a member method. So this method is related to the class restaurant. So when I say I want to set a name for the restaurant, okay, then people can call the method called set a name, and that people can provide the restaurant name. So that's why we can pass the restaurant name as parameter. And the type of the parameter is string. Okay. So once the actual people provide the name, restaurant name, and then I can assign this restaurant name to this variable name. Okay. So then I can actually, so this restaurant has a name. And then I can actually set the rating. So then people provide the actual rating, and then I can assign the rating, user rating, to the variable called rating. And then I can actually print this. Now, once you define this, So now you have the data, right? Or attributes or characteristics. And then you have the methods or operations. Now, how can I use this? Okay, to use this, we need to create an object. Okay, or we need to create many objects of the restaurant. Okay, so I can define these restaurant. I can define an object of the restaurant called FAV lunch place. It basically means my favorite lunch place. I create this object. It is the favorite lunch place is an object of type restaurant. So this is just the same as like I create a string and a my string. Okay, that's almost like the new string, whatever you can do it. Okay, so basically now here I replace the string with restaurant because string is actually defined in a class, but in the library. But restaurant is it's just a class that I defined it. So I just say restaurant, my favorite lunch place. That's the instance of a restaurant. Okay. Now that's a syntax. I put the restaurant parentheses. We're going to explain this again also later. This is called a constructor of the restaurant object. So once we create a favorite restaurant, favorite lunch place, which is actually an instance of a restaurant, and then I can set up a value, set up the name for this particular object, my favorite lunch place. What's the name of my favorite lunch place? What's the rating of my favorite lunch place? So I can set up a rating. So by calling the object name favorite lunch dot set rating. So I call the set rating. Where is the set rating? It's in this object favorite lunch. And then you need to provide a user rating. So then user rating I provided here is 5. Okay. So basically, this one will call set rating. Okay. And then pass the argument 5 to user rating. So the user rating has a value 5. And this 5 is assigned to the rating. So the value of the rating becomes 5. But that's the value of the rating becomes 5 for my particular restaurant object. Okay. So my particular restaurant favorite lunch place has a rating 5, not other object. Okay. So my favorite lunch place has a rating 5 because of I set the rate. Okay. So now let's take a look at the actual code. So I just run this code so you have a better understanding of the. Okay. So I can just erase some of the code here. And then I define a restaurant, a class called, class called a restaurant. Okay. So forget about this. I just put the public here. So let's say it's a private. Okay. So and then I have 3 methods, right? I have 3 methods. Set name, set rating, and a print. Print. What I'm gonna print is, what I'm gonna print is a printer gonna print this particular object, a particular particular name and particular rating. Say the restaurant, this restaurant name is name. So that's this one. And this particular restaurant rating is rating, which is defined here. Okay. So, and then in the main class called restaurant favorites, and then I has a main method, okay, defined here. Okay, so I created two objects. One is my favorite lunch place. Okay, this is one object of the restaurant, and my favorite pizza place. Okay, so that's also another object. So basically, I created two objects. Both objects are restaurant type. Then I call my favorite lunch place dot set name. So that means this object, and then I call my favorite lunch place set name. So basically, this is gonna call a set name for this for my favorite lunch place, and then I pass the parameter here. It's a string as a slattery, and this when I call this, the slattery is gonna be passed to the parameter restaurant name for this particular object. So the restaurant name, which is slattery, going to be assigned to a name, and the name going to have a value called a slattery. But that's the name actually for my favorite lunch place. Okay, and then I can have my rating for my favorite lunch place. So I call favorite lunch place dot set rating, and then the set rating will be called, and the number 5 will be passed to the user rating. So the user rating is 5, and the 5 assigned to the rating. So the rating get the 5. So my favorite lunch place has a name slattery and the rating 5. So then I can call a method called print. So I can print the name, which is slattery, rating, which is 5. Okay. So then let's do that. So let's just compile it. Java C, my restaurant favorite Java. Okay, so I can run this. I use the command line compiler again. Okay. Now, if you take a look at these, so let me move this a little bit here. So here, you're gonna print out the restaurant name is slattery, the restaurant rating is 5, and the second one is the restaurant name is not your average Joe's, and the restaurant rating is 4. So now how this happens, because when I actually create the two objects, so I, the favorite lunch place has a slattery, rating is 5, and then I call the print method in favorite lunch place. I call this printer, and in my favorite lunch place, when I call the printer, the name is slattery, rating is 5, because slattery is the name for favorite lunch place. So that's a name actually for this particular object. Okay. And the rating for this particular object. So this is actually then when I print, you're going to print the name and the rating for this particular object. And the same thing with my favorite pizza place. Okay. Not your average Joe. And then ratings 4. And I just print. So I print these two out. Now, so this way, I can define a restaurant. I can provide the data. I can just define the methods to manipulate the data. So what I can do is I can change it. I can change. So for here, okay. Now, if I find out my favorite lunch place is not a slattery anymore because last weekend I just went to another restaurant, and I find out a better restaurant, which is better than this. So I decide to change the name of my favorite restaurant. Now, what are you going to do? Okay, so then you can change it. So you can call favorite lunch place dot set name, and you can change the name to say, let's say coffee will be. So I just randomly just pick another one, and then so the rating I'm gonna put in here 4. Okay, so I don't have to change the rating. I still actually say the rating is still okay. It's still 5, but my favorite actually restaurant has been changed. Okay, so if I change this, I change the name, setter name, and then you're gonna call the setter name and put the Applebee, assign Applebee to the name, right? So the name has been changed. So if I actually call the print again, let me see. So that print, I can say after the name change. After the name change, now what happens? Let's actually compile it again. Okay. So after the name change, the restaurant name becomes Applebee because I changed it. So you can actually use this method to manipulate the restaurant object. Okay, I can also change the name, my favorite pizza place, to some other actual restaurant. So, which is fine. Now let's actually go back to the other topics. So why we want to use the something called private? Why we use the private? Can I actually change the private to public? Okay. Can I change this to public? Let's see. The answer is yes. Change the string name to public. You don't actually notice the change. So if you actually, execute this, new code, the result is actually the same. So you change to public, it's still the same. Not a big problem. However, now you can see because this is a public now, and it's defined in a class called a restaurant. It's a public actually variable now. So now what I'm gonna say is that now, if I want to change the name, I don't have to use the method, right? I can directly say favorite lunch place dot name equals okay. So this name is in this class object called this name is a public in the class called restaurant. So if I create an object called a favorite lunch place, and then if I can directly call favorite lunch place dot name because name is public, so I can call directly from the outside and assign a new name to the name. Okay, so now let's do this. You're gonna see that the restaurant name is Applebee after the name change. So I can use this directly to change the name. Okay. Now what's the difference between these two? The first one I use the method to change the name. Okay. Now can I use this to change the rating? Since rating is also available here. So I'm gonna say I want to change the rating to 4. And I do this. Let's check. I got one error. Restaurant favorite.java 18. So that means in line 18, I have a problem. Rating has private access in restaurant. So I cannot just call the object name dot rating and directly change the name by favorite lunch place dot rating equals 4. I cannot directly assign a 4 to that rating. If I want to change the rating, I have to call the method called set rating. Okay. Now why I cannot do this? Because rating is private. If you want to do this and make it correct, you can actually say, okay, I can change this to public, right? Now what? If I change to public, everything gonna be okay. So it's okay. So the restaurant rating has been changed to 4. Now my question for you is, what's the difference between these two? If I define these name rating as a private versus defining these name and rating as public.
One advantage I see of setting it as private and using a method to change it is if you decide to change how that rating is stored within the method or within the class. Maybe you want to rename the variable. You only have to change the rename method and not maybe you have multiple places in your code that would currently access the variable. It's just a more robust way of doing it.
Okay. So sounds to me like if I define it as a public, then I can also change using methods, but I can directly change it, right? Directly using the assignment to change it. Looks like the public is more flexible, but just keep that in mind. So sometimes if we want to create an object and we want to actually, provide a certain interface so that people can change the data through the interface we provide. We don't want people to just randomly change it. So now, why is that? It's just like an example. If we define something like, let's say we define a warehouse. Okay, we create a warehouse, and then inside the warehouse, so there are a whole bunch of aisles. Each aisle's gonna actually, put a different products, TV, videos, and so cameras and video games, so all these different stuff. Okay. Now, if you try to make you think about all the products in the aisles as a data, okay, and then you create a certain kind of a method or operation interface. You can create a front desk, okay. So the front desk, is a service place. Okay, so now if you want your actually warehouse that you create a warehouse, you provide a service, but the customer doesn't have to know the inside of the warehouse. Then all you need to know is the customer can actually go to the front desk and ask the customer service, say, I want a particular TV. I want to buy a particular TV, a particular model. And the service people can run into the aisles and pick up a TV and give that to the customer. That's one way. The other way is that you make the aisles open and then just tell customer, say, okay, aisle 1, that's all the TV. Aisle 2, that's all these networking stuff. And aisle 3, that's the computer games, IO4, IO7, 6. These are all TVs. Okay, and then the customer can actually go into the warehouse and pick up the stuff of their own. Okay, now that's the difference. However, the latter one, the one you want to actually, open the warehouse, let the people to get in, it's fine. But what we want to do is we want to create, remember, we want to create some kind of encapsulation. We just want to create an object. So people can access the data of the object, but people don't have to know the inside, the detail, the implementation of the data. So this is really not good from information hiding or encapsulation perspective, right? So that's why when we create a class, we normally want to make data private. So if we allow people to change the data, then we actually provide methods, and people have to call the method to change the data. Now, for some of the data, if we don't want people to change it, then we don't create an interface. We don't create a method. And then we basically, the user of the class cannot change this data. But if we don't want the user to change data, but we still make the data public, then even if we don't want the user to change it, they can still change it, right? Because they can directly use the assignment to change it. But if we allow them only to change it using the methods, and then we provide the methods, this is going to clearly send people the message, say, if the method allows you to change, then you can change it. If we don't provide the methods, then basically we mean you are not allowed to change these data. Okay, if we don't provide the methods to change the data, then you are not allowed to change the data. Okay, that's basically from the information hiding or abstraction perspective. It's always desirable to use the private data type. Okay, use the private keyword. Does it make sense? Okay, so once we actually define the class, then you can declare the reference variables of the class type and assign the variables with explicitly allocate the instance of the class type. So this reference variable is, can be referred to the instance of a class, and the new operator explicitly allocate the object to specify the class. So that basically means once you declare a class called a car, then we can create, so my car is an object. Also, it's called a reference variable. Okay, that's a reference variable. And then we can define a new and then a car. So this basically the new operator basically explicitly allocate the object of the specified class type. So this way we create a reference variable, which is the object of a car. Okay, so in general, car has a maker, has a model, has a color, but for each individual instance of a car or object of a car, then you need to assign the actual value for each of the variable. So for the maker, you have to assign a value to it, like a Toyota, Nissan, okay, Ford, Lincoln, okay. Okay, let's actually talk about another example. Let's discuss more examples. So I think the best way to learn this is just use the example. Okay. Now, before we start to actually write the code, let's actually talk about the bank account in general. We want to create a class called a bank account. Okay. So we need to define the class fields, the data. You need to define methods. Now let's think about data. Let's say if you have any bank account, like your checking account, your savings account, okay. Now, what kind of data you need to define for your bank account?
Your balance.
Okay, your account balance, right? Now, because you want to create a bank account called a class called a bank account, but you want to create each individual bank account, an object of the bank account, like my account, my checkings account, Brady's saving account, Brady's savings account, Brady's checking account, or so whatever account you want to create many instances of them. So for each account, so generally for each account you need a balance, right? What else do we need?
So wait, are you saying that we need multiple fields for all those different accounts within the bank account?
We need a multiple object, multiple instance of account, but for each account, instance of account, the field should be the same. So each account should have a balance, right?
Oh, okay.
And what else we need? We need account name. Who owns the account, right? What else do we need? You can create as many field as we can, but we just want to create some necessary field for each account.
Would you have an account number, or would that be the instance? Like each instance has its own ID, right?
Yeah. So you have account ID. That's probably used by the bank, right? So they want to differentiate each different account. So each individual account should have a unique ID, right? Account ID should be the one. Yeah, just like a account number or account ID. Now let's go look at the methods. So if we want to do some kind of operation for the account, what kind of methods we need to define to manipulate these account data? We need to deposit, right? Okay, we need to actually deposit. And when we do the deposit, we need to provide an amount, a dollar amount, right? So that could be double, because we talk about money, you can use double, but you can use actually formatted printing display to print to only display actually up to 2 decimal place. Okay. What else we need?
Withdraw.
Withdraw. Okay. And also we need to specify the withdraw amount. Okay. So when the user of account wants to withdraw, and you have to provide a withdraw amount, right? Anything else?
Probably a check balance, just like a general
Okay,
check on the accounts balance.
check balance or get balance, whatever it's called. Okay. Or we can say check the ID, account ID. check account owner. Right? We can do this. Think about this, okay? Can we actually define method who can transfer the certain amount of money from the current account to another account?
Yes, I think so.
Okay. Let's say transfer. So now first you need to define how much you want to transfer, right? Double amount. Now in order to do the transfer, you need to provide another parameter. What is the other parameter?
Would it be the ID?
Now when you transfer, if you are currently in the current bank account, your current bank,
Oh,
but you
yeah.
want to transfer to another account.
So you need the ID of the other account.
You need the ID of the other account, right? Okay. Okay. So then, or we can say whatever the account, other account. But this it's a type of bank account, right? You can put the ID, but I think the bank account should be enough. I guess we'll see. So when you transfer, you need to specify how much you want to transfer and which account you want to transfer to, right? So that's the bank account. So it's another variable, which is actually bank account type, you know. So you want to transfer to another one. Then here's the other account. Okay. So I'm running out of space, so I just insert here. Okay. Well, I guess that's good enough. So then I think we're running out of time, but I think next class on Monday, we're gonna actually talk about how to implement these bank account. Okay. And just provide the implement details for this bank account. So maybe at this moment, if you have time or if you want, then you can actually check this one and start to actually think about how to code this program. Okay, how to write the code for this program. And also, if you have more questions or if you something you're not sure about, and then you can ask a question, and so you can actually put your question in the discussion in Blackboard. So I'll check the Blackboard during the weekend. So maybe on Monday I can check the question if you have any questions, and we can check the question, or we can actually go ahead and work on these examples. Okay. Okay.
All right.
Any other questions? Well, stay tuned, and we'll be back. So I hope you have a good weekend.
Thank you. And you too.
You too.
Yep.
See you, Professor.
Thank you, Professor. Have a good weekend.
Bye.